Okay, so today we are to learn how to run analysis on truss using the method of joints. How to run analysis on truss using the method of joint. Okay, so this is the structure. This is how the structure is. So this is the structure. So we have to determine whether the structure is statically determinate or statically indeterminate or unstable truss. So this is the formula. M plus R is equal to 2 is statically determinate truss. Okay, so M stands for the number of members, R is number of reaction, and this one, and 2J is, and J is number of joints. So M plus R greater than 2J is statically indeterminate truss. So M plus R less than 2J equal to unstable truss. So M plus R 2J. So we know M is number of members. So what is the number of members? 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 members, so 9 plus. So how many reactions do you have? So the pin support have 3 reactions, which we have something like this. So it has 3 reactions. 1, 2, 8. The pin support has 2 reactions. Sorry, 1, 2, and the roller support has only 1 reaction. So number of reaction will be 1, 2, 3. So number of 3. So 2. J is number of joints. So how many joints do we have? We have 1, 2, 3, 4, 5, 6. So times 6. So 9 plus 3 is 12. 9 plus 3 is 12, and 2 plus 6 is 12. So it is equal to. So if M plus R is equal to 2J, then the structure is statically determinate truss. So we are going to write, therefore the truss is statically determinate, is statically determinate. Okay, so we have an unknown reaction, which is this one. So we have to find the unknown reaction. So we have this one will be reaction H A. Let's name this one as VA, and this one to be VD. So we are finding the number of reactions. We are finding the unknown reaction. So we have the three equilibrium equation, which is sum of forces along the horizontal axis and sum of forces along the y-axis and the sum of moment equal to 0. So this is the three equilibrium equations. So we have to first find the sum of forces along the horizontal axis. So let's state it: sum of forces along the horizontal axis, sum of forces along the y-axis. So sum of forces along the horizontal axis, we are going to have HA because it is on the horizontal axis. So first of all, let's state our sign convention. So this is our sign convention. So y-axis to the down is -1, y-axis to the top is positive, x-axis to the left is negative. So we have this force, which is HA, which is on the horizontal axis. So it is pointing to the right. So to the right is positive. So we are going to get positive HA. So HA is positive plus this force too is on the horizontal axis. So 80. So plus 80 is equal to 0. So we have to make HA the subject. So HA will be equal to the 80 will cause the equal to sign to be negative 80 kilonewton. So it is negative 80, so we can write it as or 80, then we'll bring the reaction sign or the force sign. So we're going to get something like this. It is pointing to the left because it is negative. So it is pointing to the left. So the sign convention states that if the reaction on the horizontal axis is pointing to the left, it is negative. So negative 80 will be pointing to the left. So that is it. So we have to find the sum of forces along the y-axis, which is sum of forces along the y-axis equal to 0. So we are going to have the VA, which is pointing upwards. So we're going to have VA, and which one? We are going to have the VD, which is also pointing upwards. So plus VD. So we are going to have 50. This force is pointing downwards, so it will fall under negative sign. So we are going to get negative 50 or equal to 0. So the 50 will cross the equal to sign to be negative 50 will cross the equal to sign to be 50. So let's bring our VA plus VD.